Welcome to module 12. In this module, we will go through the life cycle impact assessment further. Here we will go through a example calculation quickly to show how LCIA is converted into LCIA. Then we will go through the theory of characterization factors, which are the characterization models, and then we will look at the various LCIA methods and the conversion of midpoint to endpoint indicators. So, we will begin with this activity, which is to convert LCI to LCIA. In the last module, we went over how to convert it. So, in this question, you have to use the given LCI data to perform LCIA in following impact categories. So, the impact categories that you need to calculate are marine ecotoxicity, human toxicity and terrestrial ecotoxicity. The LCI here is giving you all the material inputs and the emissions and waste and the products and co-products from the life cycle assessment that you have done. And the characterization factor is provided for you to use for the LCIA. So, take 30 seconds and we will get back to see what the marine ecotoxicity for this particular LCA would be. So, when you calculate marine ecotoxicity, what we have to see is we have to see what are the contributing factors to marine ecotoxicity. So, we have benzene in air and the sub compartment is high population density, and benzene in water. Characterization factor is given in terms of kg 14 dB equivalent. In our emissions, so we will see that we have benzene in the air and also the benzene in the water. So, we have 5 kgs of benzene going to air and 2 kgs of benzene going to water. So, when we calculate the marine ecotoxicity, we multiply the characterization factor 8.30 10 to the power minus 4 with the 5 kgs of benzene that is going to air in the high population density area. For benzene in water, we have 2 kgs of emissions and the characterization factor is 1.30 10 to the power minus 3. So, we multiply 1.30 10 to the minus 3 by 2 and that gives us the total marine ecotoxicity of 6.75 into 10 to the power minus 3 kg 14 dB equivalent, which is the reference chemical for this impact. Similarly, you can calculate human toxicity and terrestrial ecotoxicity. So, you have to look at the right characterization factor and the terrestrial ecotoxicity. So, this is a simple example of how you can convert your LCIA into life cycle impact assessment. For most of the softwares, this is done automatically, but if you are dealing with some new chemicals and you have new characterization factors, you can do it manually. So, let us go further into the theory. So, we have seen how we use the characterization factors to calculate the impact in the certain category. What is the science behind developing this characterization factor? So, the question comes at where do these characterization factors come from and how are these characterization factors calculated? So, the characterization factors are calculated based on characterization models. What are these characterization models? These are physicochemical models that are based on chemical characteristics. So, whatever chemical you are looking at, what is the characteristic of it, what is the fate of pollutant, so where does it end. So, you saw that the characterization factor for benzene in air versus benzene in water is different. So, the fate of pollutant is also considered and other factors that contribute to the impact of a component in a category, and that could include the exposure and all. And of course, for various impact categories, you have different models. So, you are really looking into how this chemical is going to behave when it is released in the environment, and based on that physicochemical interaction, we develop these models to calculate characterization factors. So, let us look at an example. We will look at the characterization model for global warming potential. So global warming potential is the impact category that is used mostly for climate change assessment, and IPCC uses it for also understanding what is the impact of certain emissions on the global warming. What it does is that this model is a detailed physical chemical model that relates the LCI component to a particular impact. So in this case, the question is that how does CO2 impact global warming, or how does methane impact global warming? So the characterization model in this case would be a physics model that includes atmospheric reflectance, because global warming is based on how these particles or these gases are actually absorbing the infrared and the heat, and that is contributing to the overall warming of the atmosphere. So it includes atmospheric reflectance, absorptivity, which is the absorbance of some of the heat transfer, etc. for the molecules. And each molecules, if you go back to your chemistry lessons, has a different capacity of absorbing or not absorbing the heat. So for each component, your GW would be defined differently based on its chemical characteristics, and that's where your characterization factors come from. So the GWP model for the characterization factor is defined as the ratio between the increased infrared absorption it causes and the increased infrared absorption caused by 1 kg of CO2. So remember, in the characterization factor we have a unit. For GWP, it's the kg CO2 equivalent, and the reason is that this characterization model calculates the global warming potential of every other emission in reference to the global warming potential caused by CO2. So here you can see that your GWP-TI is given as integral of AICIT dt, where CIT is the concentration of greenhouse gas at time t after release, so it is in kg per meter cube. AI is your radiative forcing per unit concentration of greenhouse gas, and then you integrate it over time. So that is why GWP, either you will see that people report GWP either for 50 years or GWP for 100 years. So when you have that accumulation of the gases over the number of years, it causes an increase in the infrared absorption, which has overall increase in the global warming. And the denominator is your integral of ACO2 and carbon CO2 times dt, which is mainly the concentration of carbon dioxide over time, how it is changing, and the radiative forcing for carbon dioxide. So therefore, if you calculate this for GWP for CO2, the characterization factor comes to be 1, because it is in reference to the chemical. So whichever reference chemical you uses for your characterization model, the characterization factor becomes 1 for that chemical, and then all other chemicals are ranked in reference to that particular chemical. So since the GWP value is based on relative value to per kg CO2, all the characterization factor for your LCI components are actually reported in kg CO2 equivalent impact per unit of that component, and this is the source of units for impact category. So whichever impact assessment method you are using and you see what is the unit reported for that impact category, you know that that is the reference chemical which has been used to develop the characterization model for that particular impact category. And that is why the characterization factors are based on actual science of how the chemicals behave. However, it's not really risk, because we are just calculating it at a time stamp and then we are using it as a factor. So now how do LCIA method differ? This is where the LCIA methods differ. They are based on different characterization models which provide characterization factors. So when you delve deeper into different impact assessment method, you will see which characterization model has been used by that particular impact assessment method, and the impact categories that are included will also differ. So whenever you pick an impact assessment method, you would need to understand which characterization factor has it used. Is that really applicable for the impact you are looking at? And if it's not, then you pick a different impact assessment method. So let's look at the LCIA method evolution. So we have, in the last module, we quickly went over this, not into depth, but it started in 1984 with the volume critiques method, and then it has today evolved to Impact World Plus, and most of the times we are using actually the recipe or the CML methods. So, we will go through these methods one by one, just briefly to see what is there in these methods and where these methods slightly differ. But whenever you have to actually do your impact assessment, I would recommend looking into the handbook of LCA and going through the impact assessment characterization models to be able to pick the right impact assessment method. So, let us look at the earliest approach at impact assessment. This was the critical volumina approach, and it was very simple. It is not about how something is being impacted, but it is more about how are we really polluting the environment. So, the principle for this was that you calculate an equivalent amount of air, soil or water that is required to dilute a pollutant emission in the respective environmental media up to a threshold volume. So, for example, if I had clean fresh water and my process or my product resulted into polluting that water, then we will need to add additional water to reduce the concentration of that pollutant to a certain threshold value. That extra volume of water is what we call as the critical volume that is required. So, here we are using kind of a proxy method to calculate the impact. So, we are not actually calculating actual impact, but only the resource that cannot be used due to higher level of pollutant. So, you have to add that extra volume which is equivalent to the amount that was pollutant and cannot further be used. So, this is a very simple approach because this is kind of really taking into how much of the resources are taken away by that process by polluting it, and you have to actually replenish the resource to be able to use it, and that is what the earliest method of impact assessment was in terms of critical volumes of resources that are being polluted. Some of the recent LCI methods are CML 2002, Eco Indicator, Impact 2002, Lime, Recipe and Tracy, and we mostly use CML 2002. Most of the softwares have that, but of course you have all the choices available, and most of the softwares will provide additional impact categories. CML 2002, it is used in almost all studies, and study specific impact categories may be included in appropriate goal and scope. So, if you want to read more about it, you can take the handbook on life cycle assessment and you can actually delve deeper into the impact assessment methodology. Some of the impact categories in CML 2002 are the baselines. One are depletion of abiotic resources, impacts on land use, climate change, human toxicity, ecotoxicity that includes all the freshwater, marine and terrestrial, photooxidic oxidant formation, acidification and eutrophication. Then there are studies specific such as impacts on land use, loss of life support, loss of biodiversity, ecotoxicity, but there are also others such as depletion of biotic resources and malodorous water. Eco Indicator 99, this is more of a damage oriented impact assessment method. So, here you have 11 midpoint categories, but you also have 3 endpoint categories that includes the damage modeling for human health, ecosystem quality and resource depletion. So, the Eco Indicator, if you want to read more about it, it is available in this book, which is on the damage oriented method for life cycle impact assessment. Then Impact 2002 plus, it is mostly the impact assessment of chemical toxicant, and it has a combined midpoint and damage approach. Here you will see that there are they include 4 damage categories at the endpoint. So, you have of course the usual human health, ecosystem quality and resources and climate change. So, climate change is the additional one that they include as the endpoint category. So, they have currently about 1500 to 2000 LCI components, and it is available by the Swiss Federal Institute of Technology. So, if you want to read more, you can go through this user guide to read about this impact assessment method. The midpoint impact categories in Impact 2002 plus, they include global warming, human toxicity, respiratory, some of the usual ones. We also have ecotoxicity, and it also has land occupation as one of the impact. Then we have the recipe. Recipe is more hybrid. It combines the midpoint approach of the Dutch CML 2002 with the damage indicator of damage approach of Eco Indicator 99. It has 18 midpoint categories and 3 endpoints such as damage to human health, ecosystems and damage to resource availability. Some of the midpoint categories are our usual suspects of climate change: ozone depletion, acidification, eutrophication, and also the human toxicity and the ecological toxicity. It also has additional agricultural land occupation, urban land occupation, and natural land transformation. So, it does focus on how your process is affecting the land transformation, which is an important sustainable decision criteria if you are looking at the impact of your emerging processes. Then there is TRACY. TRACY is very US specific. It is a tool for reduction and assessment of chemical and other environmental impact. It is developed by US environmental protection agencies, and it is mostly at the midpoint category. Also, the normalization database is consistent with the TRACY's impact categories and inventory flows. So, here weighting is not recommended. We will in this module we will go into normalization and weighting in a bit, so you will know what that means. These are the midpoint categories, which are also our usual suspects of acidification and global warming and ozone. One thing you will notice that in all of the impact assessment, we have global warming and ozone depletion, acidification, eutrophication. Our usual suspects of impact are mostly available. They might differ slightly in terms of the characterization models that they are using. So, some of the characterization models recommendation from handbook of LCA is whenever you have classification as 1, that is the one that is actually recommended by the ISO to use. So, for example, for climate change, you have the best among existing characterization models, which says that there are multiple characterization models for same impact, but which one is the best that has been recommended by most of the users of LCA or the recommended by ISO. So, there is baseline model of 100 years of the IPCC, that is the best model for climate change, and that is classified as 1, which means that is the one that is recommended. If you want to use something else, of course, you can use, and you report which impact assessment method you have used. Similarly, we have ozone depletion, we have the steady state ODPs from the WMO assessment. For human toxicity, both the cancer and non-cancer US ETOX model, for which is available in the TRACY, is actually really highly recommended in terms of second and third. Similarly, you can go through this ranking for each of those, and this is available in the handbook of LCA. So, in brief, if you have to make a decision about which impact assessment you are going to use, I would recommend to have your handbook of LCA ready, so that you can go through the characterization models and see what is being recommended by the LCA community to use for the particular impact category that is the focus of your LCA. Similarly, we have on the ecotoxicity and everything. So, now we will go from midpoint indicators to endpoint indicators. So, we have seen that from the LCI results, we can go to the midpoint indicator by using the characterization factors. Most of these characterization factors, as we saw, are based on some of the characterization models. How do we take these midpoint indicators and then convert it into endpoint indicators? For that, we use what we call as damage models, and what the function of damage models is that it takes each of the impact and then it converts that, or it converts these emissions into each of the area of protection by saying how this is actually damaging human health, how it is actually damaging natural environment and natural resources. So, for example, an experimental study could be that if there is a rise of temperature by 1 degree Celsius, how are the plants going to respond? So, that is actually the impact of climate change on natural environment, or even natural resources, how we are obtaining different agricultural resources, and that is currently a huge area of study, but there is not a consensus. So, it is still under development to create those damage models for these of midpoint categories on the protection areas of natural resources or natural environment. So, some of the approaches to characterization in damage category. So, when we create this damage, there are 3 different viewpoints. One is the egalitarian. Egalitarian viewpoint means that it takes a very long time perspective. So, from a sustainability aspect, this is really good because it is actually valuing the future much higher, and it is saying that even if there is a minimum scientific proof for justifying that this particular midpoint category is damaging human health, we must pay attention to it and we must include it in our damage category and develop damage models. Individualist is more of the short time perspective, whereby only proven effects are included. When they say that, okay, there is a doubt, we don't have enough data, but that is why we will not include it. So if there is not a conclusive evidence, they will not include it. Maybe there are 1 or 2 data points, so they will disregard it. That's more of an individualist or a short time perspective for sustainability. Then there is an hierarchist approach, which is more of a balanced time perspective, whereby consensus among scientists determines inclusion of effects. Of course, this takes time, because you have to develop consensus by thorough experimentation and evidence gathering and all of that. So hierarchist is actually the best, one of the best way of looking at it, because it is taking a balanced approach. It's not becoming too conservative by saying we are really damaging, and it is not being too ignorant in terms of saying that it's not showing more effect because there are only 1 or 2 data points. So whenever you look into the impact assessment method, you will see that there are characterization factors based on different approaches, viewpoints like egalitarian, individualist and hierarchist. That is mainly looking at the time stamp and collecting more data. So in most of the softwares, hierarchist is the default option, but you can of course be more conservative in your impact assessment and use the egalitarian or an individualist approach, and or you can also use all three and compare what it is telling in terms of the damage that is caused by the certain impact categories. So let's look at one of the damage models. Here we are calculating human toxicity and ecotoxicity modeling. So we have all the emissions in compartment and fraction transferred to A. So what it is doing is, let's say we want to calculate the human damage factor, where we are taking some emission and calculating till the end point. So your SDFI is the human damage factor in disability adjusted life years per kg emitted. Your IFI is the intake fraction. So intake fraction is where you have chemical fate and human exposure. So you are really looking into the impact of that chemical and human exposure. And then EFI is the effect factor, which is saying that how much is actually it affecting. So we are starting from emissions in each of the compartment, the fraction transferred to N, where we are actually looking at the impact, then time integrated concentration over time, how much is actually being accumulated. And see, there are two pathways, one is the human exposure and the other one is the ecological exposure. So for human exposure, let's say it's in air and we have some toxic chemical that we breathe in, so that's the dose taken in. Risk of affected person, so we calculate the risk, and then the damage to human health. So this from here to here is the human exposure, how much we are exposed. Here to here is the chemical fate, where it is going, and from here to here it's actually looking at the response of the humans to that chemical. So when we combine all that together, intake factor and effect factor, we calculate SDFI, which is the human damage. So we are taking all the emissions and going all the way to the end point. Here of course you see that we are not in between calculating the midpoint climate change, but we can also incorporate it here by incorporating the characterization factor and just calculating the climate change impact. Similarly, for the ecotoxicity, the same thing, fate factor is how much of it is going to the ecosystem, then effect factor is basically looking at species exposure and potentially affected fraction of species, and time and space integrated damage on ecosystems. So this is what the damage modeling approach is, that you are actually looking at where each chemicals are going in terms of the end point or the end point indicators in terms of human health damage or ecosystem damage or the natural resource damage. So for that you would need to actually do a very detailed study and understand the impact by calculating evidence on those endpoint indicators. So you see, there is this time integrated concentration. For egalitarian, you would do a long time integration. For short time, for individualists, they will take a short window and they will say it's not actually affecting and they will ignore it. And for the hierarchists, we will take a much balanced approach. So that is what the damage models approach is, that can take the emissions all the way to end point, but it can also take the midpoint to the endpoint category. So I have already talked about in terms of EFI, which is the risk of incidence, and DI is the severity. So, in summary, for LCIA methods, depending on which LCIA methodology is selected, your impact categories at midpoint or endpoint will be different. Each LCIA methodology differs in the characterization model, which results into variation in characterization factors. So, when you are selecting, you would of course go through the recommendation for picking the best characterization factor for that particular impact category, and so you have to choose your LCIA wisely. Sometimes a LCIA method will have characterization factors for some impact categories which are really good, but some of them are not very well developed. So, in that case, you do have to make a judicious call of which one you are going to pick depending on the goal of your study. So, remember, when we set up the goal and scope, we also pick the impact assessment. So, if your goal is climate change, then you pick the impact assessment method that has really the best characterization factor for the climate change, and rest is okay. Similarly, if your goal is human toxicity, then you go for the characterization factor model or the impact assessment method that has the best characterization factor for the human toxicity. So, you do have to make those judicious calls in case you are developing LCIA or picking LCIA based on your goal of the study. So, next we will go through the non-mandatory steps, which are the optional steps of normalization and weighting in the life cycle impact assessment method.